Very good morning, all present here. Today we are going to have most interesting, important topic, the field of industrial automation. So the title of today's presentation, Importance of Simulation in Robotics, a case study by Dr. P. Sivashankaran, Associate Professor, Department of Mechanical Engineering, Manakula Vinayagar Institute of Technology, Pondicherry. So this is my proposed plan of product presentation, which are listed here. Abstract of project idea, introduction about the project theme, problem objectives, literature survey, methodology, and then conclusion, future scope of work, and literature references which I have collected so far. Now let us go with the ideology or abstract about the project work in the field of robotic simulation. So in this work, major attempt has been carried out to study the impact of simulation practices through offline programming application with the help of a virtual robot using RoboDK solver package. In this case study, the production tasks like machining, welding, these are some of the examples took in the case study to simulate these various activities with the help of RoboDK package. And based on that, identifying the challenges that are addressed inside the work cell with the help of the simulation assistant programming language. Next one is introduction about the robotic simulation, the current recent practices. Due to the modern industrial advancement, the simulation has been acknowledged as a key important tool, not only in academic institutions, also in industrial sectors. So this has become the focused attraction in today's the public point of view. Through simulation, we can able to design a 3D model, and also we can plan, analyze, and take a proper decision to measure the remedial steps to improve the system efficiency. So in this work, a virtual robot is designed and the arm positioning is planned in such a way that arm must be free from all obstacle detection when the activity or any work is going on inside the work cell system. So further research and development studies are conducted to better position the manipulator arm of a robot, the corresponding path axis, in order to smoothly carry out the given assigned task. The simulation process simplifies much better and gives lot of benefit in both virtual and also physical world. So there are two types of application interface in robotic simulation. One is online, another one is offline programming method. So using any one of this method, we can able to analyze the kinematic motion of a robot in order to accomplish the task. The problem objectives are listed out here. Simulate the various manufacturing tasks like machining, welding, with the help of the virtual assistant. Analyze the arm kinematics of a robot with respect to the coordinate axis. Determine the collision mapping of a manipulator arm within a given voxel system to avoid the accidents. These are some of the key literature work done in three broad areas of simulation. First one, in education industry, how the simulators, virtual simulators are used to improve the quality, efficiency of the classroom teaching. Next application, robot simulator softwares in factory operations in manufacturing, assembly line. So these are the three broad areas of literature which are collected so far. So in the above survey, it is clearly evident that the importance of simulation has gathered a lot of attention for researchers to contribute their valuable ideas in three broad areas like teaching and education field, manufacturing sectors, etc. So among the three broad areas here in my project work, I have chosen the manufacturing simulation as a primary focus of study with the help of robo solver. And the next, the part of the slide, we are going to see the methodology, how the simulation can be done with the help of the robo solver. So this workbench is considered to be the default the workbench of robo solver package. So how to install a virtual robot in the workbench? So go to File menu, click File menu, choose Open. So click the Open tab and browse a different the source of the robotic machine which you are going to install in the workstation system randomly. Click any one of the virtual robotic assistant model, 3D model. Click and mount it on the workbench. And we need to perform the collision mapping in order to check whether the arm manipulator of the robot is free from obstacle detection or not when the job is about to carry on within a production shop. So for that, go to Utilities option, click Utilities, then select Collision Mapping Planner. So a pop-up dialog box will be open like this. Here we can able to run number of iterations and we can able to select the the path generation of a robotic arm by following any of the two methods, random joint method or a fixed tool orientation. Here random joint. So here arm will move randomly in order to sense or detect the obstacle which is kept nearby the work system, based on which it will modify the position of the arm, okay, where there was no obstacle, right? So that we can prevent the collision or an accident when two machines are working parallelly within a given shop floor system. So this experiment is run for nearly 79 iterations, and the given degrees of freedom is commonly fixed to be 3. So collision mapping is one of the primary exercise which is carried out to perform the mechanism of arm type robot in order to position the path in various orthogonal coordinate systems, say x, y, and z axis respectively. While performing the analysis, it is noted that the obstacle placed within the workstation is detected with the help of the virtual sensor, and based on that, it realigns the axis path motion of the arm. So everything we can do it, test it through simulation mode. And the total runtime of the experiment is 35 minutes to do all these kind of an experiments, obstacle detection. The number of collision hits is measured to be 10. So every time when the collision is detected, arm gets stopped and it will find the next new position or a path to change the axis of rotation, arm rotation, in order to do the given task. The future scope of work, the same domain can be extended in order to improve the facility planning or the plant layout of a given workstation to increase the operational effectiveness of the manufacturing shop by using plant simulation softwares like Technomatics, FlexiSim, etc. These are some of the reference journals I cited out as listed here. So thank you one and all. If you have any queries, just you can contact me at any time through email or any other facilities. Thank you one and all present here.